So now we are going to talk about IP design, how we can design IP to get relevant protection for our project. So we know that IP rights should focus on customer benefits because that's where the added value is, and so that is what we need to protect. So we need a method, a tool to identify where we can implement IP in a business model. Starting from the customer point of view, and this tool should take into account all the possible variation of using this business model. This can be done by a combination of different design thinking methods. Here you can see the cognitive walkthrough, and we have the AEIOU method. So the cognitive walkthrough is a systematic analysis of activities, and the AEIOU method is a framework to collect and to organize information according to different categories. So here you have the environment, which is a space where the activity takes place. You have the interaction, that means interaction, person-person interaction, or person-object interaction, object-object interaction also. We have the objects, which are the system component, and the user, because we can have different groups of users and they can have different needs. So when we combine those methods, we can we get the swim lane illustration. So we have each category at each step of the process. So we get a holistic view of the different scenarios. We're going to apply that to a practical case. So we start with a cognitive walkthrough. And what is important here with the cognitive walkthrough is not just splitting the activity in tiny steps, it's that it is the customer walking through the process. First, in our example here, in our case, the customer needs to select his parking preferences, if he wants some kind of location, some kind of added services. Then he has to communicate the parking preferences. When he goes to the garage first, he needs to be identified. Then he enters. He looks for the parking place that has been assigned depending on his preferences. He parks his vehicle, and so on until he leaves the garage.
So next step after the cognitive walkthrough is to try to apply the AEIOU, to specific steps of this cognitive walkthrough. For example, in this case, we analyze when the user enter, and after entering, looking for assigned parking bay, parking the vehicle, and having a feedback. We start from these basic activities, and we go down and we first identify which is the environment where this activity takes place. Then the object or the system components are used for this activity. Then, of course, the user who will do this activity, so the user population which will be affected by this activity, and then finally the interaction among them. If you look at this first example, where we're looking for an assigned parking bay, we need first a self-explanatory navigation system. But what it doesn't mean, we find these objects which are part of our proposition, and we say, okay, for this activity, we need, of course, signage, we need parking guidance systems, modular cells, and a lighting system which guide the user through the system, so through the parking. And then, who are the user which are affected by this activity? For example, in this case, are the price-sensitive parkers or ultra-small parkers, but generally, most of all of them. And finally, what we would want to highlight is the interaction between human beings or things, or human beings with things. And here, for example, we highlight some interaction, for example, between the parking guidance systems and the vehicle. So, which the parking guidance system will track the vehicle down to the good slot. And what does this framework give us? It's a way to organize and collect all the data in a single and understandable way, to be able to highlight afterwards key features and key interaction which are needed.
Now we try to find some match point of the customer benefits with technology in this concept. And as we learn that, we know that the customer benefit is where this leverage of maximum awareness to pay by the customers. And in our case, is how we can satisfy the individual parking preference. And here we give you some examples of no obvious tasks in real life. And for example, we can recording the user parking performance, and when drives comes again, and we can provide him where he can park now, and we can evaluate the occupying situation to provide drivers with real-time information, and we can directly use into the parkway if he are not good driver, and we can also ensuring the availability of parking space as booked, and also computing the parking fee for the parking space booked. And all these are elements which are potential environment which can generating the uniqueness by means of IP, and but we need to fuse the analysis and specify such uniqueness environments.
After we identify the real-life tasks which are related to the customer benefits, we can start with the isolation of the invention course, so actually thinking about what can we actually protect. And this, how we do the isolation of the invention course is actually a parameterization of the task. And so we need to transform the real-life task to a generic technological task. And that is done by breaking down the real-life task into different tasks which are then related to technology. We have a specific example here. The real task that we identified in the case study is the parking of a car in a parking bay. And if we break down this real-life task in the individual tasks related to technologies, we can see that first you need to identify free parking space. You then need to compare whether my vehicle actually fits into the parking space. The next step would be then to determine if my car is really well parked inside the parking bay. You need to mark out also the customized parking space, and you can also, all of these steps could be combined with providing assistance with the parking process. So each of these technological tasks are defined as potential cores that could be protected by IP, for example, by patents. And the next step would be to take a look at all of these technological tasks and then perform a prior art search to check whether they are novel and inventive if you want to go for a patent protection. And the next step would be then to discuss or determine the alternative technical solutions, which Akim is going to explain.
About IP design in an innovation process, and we think about a nice or a good or a positive parking experience in a car park. And this might sound simple, and as we've seen in the design thinking approach, a lot of tasks, real life tasks, and a couple of technological tasks where here we are only talking about one example. And one example out of these technological tasks we can deal with now on this slide here is the marking out of the customized parking space. And this is to show that out of one, only for this one example, we would find a lot of possibilities to go ahead for IP protection. So what are we talking about? Marking out of the customized parking space means, can mean on the one hand, how can I guide the driver to the parking space first, and second, how can I then achieve that the driver parks the car in the parking space as it should be, and not one wheel or maybe two wheels on the neighboring parking space. So, as you cannot read here, we talk about variable parking space marking. This requires information about the space, which I will explain, and the display of the marking in the very end. So, what can we what do we mean when we talk about the space requirements, or what do we need for this? First, I need the vehicle dimensions. How can we derive the vehicle dimensions? First idea might be you have a database which, when you enter, I have a Fiat Cinquecento, which knows then, okay, that it has whatever, 3 meter length, 1 meter width, or 1.5 meters, 2 meters maybe, I don't know. So you can determine vehicle dimensions, or you use sensors, whatever. Second point would be to determine the occupancy situation in your car park. This is a simple database request, I would say. And then you would match this information which you have here to, in the very end, determine which parking space or which parking bay would be suitable for your car. First thing. Second point, display the marking. So now you know where to park your car. No, you don't know where to park your car. The car park knows where to park your car. So this has to be shown to the driver. This is here, display the marking. This can be done maybe a bit exotical in a mechanical way. I will show you ideas in an optical way, or inside the vehicle itself. So, a mechanical way, next couple of ideas. You can have variable limitation bars, you can have variable partition walls, or you can have variable partition curtains, like this one here, to show on the one hand the way to the parking space and also the way into the parking space. As mentioned, maybe a bit exotic. Don't know whether this would really be realized, but at least it can be used for blocking alternatives. Second point, which might be a bit more realistic, you can have an optical solution with a projection system, like this one here, projecting it on the road. Maybe same thing here, floor surface, changing colors, or LED lights integrated in the floor, in the walls, in the ceiling, wherever you want. So again, a couple of solutions for your technological tasks, for one aspect of the technological task. And third point, also to display the marking. You can of course display it in the navigation system of your car or in a heads-up display, which again requires next couple of ideas, some kind of well, information exchange between the car park and your car. So how to solve that? A couple of ideas are there. So you see, just one example out of many examples for the simple task to park a car, and plenty of ideas, plenty of IP.